Ever feel like you're trying to build quality software, but you're like navigating a jungle blindfolded?
Yeah, yeah, I know that feeling. There are so many different things you could be doing. It's easy to get lost.
Right, totally. It's like, where do you even begin? Thankfully, that's exactly what we're diving into today.
We're jumping headfirst into Quality Tactics by Markus Harrer. It's a deep dive into building software that doesn't make you want to pull your hair out.
Harrer really gets into the weeds, like he bases the whole book on these things called ISO 25010 standards.
Which, for our listeners who might not be familiar, are basically the gold standard when it comes to software quality.
Exactly. And we're not talking about just a handful of tips here. This book is packed with over 400 different tactics to make software better.
400.
Okay.
So we're definitely not covering all of those today.
Definitely not. Don't worry. We've sifted through and picked out some of the really good stuff.
Yeah, we're focusing on the quality characteristics that really make a difference, the ones that will actually impact your experience as a user. And we'll make sure to bring those to life with some real-world examples as we go.
Sounds good to me.
Okay, so let's unpack this thing. Where do we even start?
Well, like any good building, you got to have a solid foundation. Right?
Yeah.
So for software, that foundation is functional suitability. Basically, does the software actually do what it's supposed to and do it well?
Seems pretty straightforward at first glance, but I have a feeling there's more to it than meets the eye.
Oh, absolutely. It's not just about whether the app works, it's about how well it works. We're talking about things like completeness, correctness, and appropriateness.
So, does it have all the features it needs? Does it actually work without bugs? And is it even the right tool for the job in the first place?
Exactly.
So give me an example. What's a tactic that developers use to actually nail this whole functional suitability thing?
So one tactic that can be really effective, though it's pretty intense, is the on-site customer approach.
Mm-hmm.
Basically, this is where you have a customer actually become part of the development team.
Wow, talk about getting your hands dirty.
Right. It can definitely be a bit tricky to manage, but having that constant feedback loop can be invaluable. It makes sure the software really aligns with what the customer needs, prevents those lost in translation moments.
So it's all about building the right thing right from the start.
Exactly.
And obviously, not every project can have a customer embedded in the team like that. So what are some other ways to make sure functional suitability stays front and center?
Well, Harrer talks about things like rigorous domain modeling. That's where you really map out how the software is supposed to work in the real world, And then there are user stories, which are kind of like mini narratives about how people will actually interact with the software.
Makes sense. It's about being proactive and making sure that the software hits the mark from a functionality standpoint. But even if the software works perfectly, what good is it if it's a nightmare to use?
Oh, you're totally right. You could have the most powerful, feature-rich software in the world, but if it's clunky and confusing, nobody's going to use it.
Exactly.
And that brings us to our next quality characteristic, usability.
And believe me, this one's close to my heart. There's nothing more frustrating than trying to navigate a website or app that seems determined to make your life difficult.
Tell me about it. Sometimes I feel like I need a map and compass just to find the settings menu.
Right.
Usability is all about making software intuitive and easy to use, making it easy to learn, easy to operate, and as error-proof as humanly possible.
So how do developers actually achieve that? What are some of the secrets to good usability?
One tactic Harrer talks about is progressive disclosure. Have you ever used an app or a website that just felt totally overwhelming at first glance?
Oh, yeah. You mean like a million buttons and menus all at once?
Yeah.
Information overload?
Exactly. That's exactly what progressive disclosure tries to avoid. Think of it like a guided tour. Instead of bombarding you with everything all at once, the software kind of reveals information and features gradually as you need them.
That makes a ton of sense. Actually, now that you mention it, I think a lot of the apps I use do that really well.
Yeah.
Like it doesn't feel overwhelming, even if there's a lot going on.
Yeah, it can be a total game changer, especially for software with a ton of features.
For sure.
It's all about making the experience less intimidating and more, enjoyable.
Exactly.
And that's just one of the tactics. Harrer also talks about creating a consistent user interface so everything looks and feels familiar across the entire app. And then there's contextual help, so you're giving users the information they need right when and where they need it.
It all comes back to that user-centric approach, right? Like designing software with the end user in mind every step of the way.
Absolutely. Because at the end of the day, software is meant to be used by real people.
Exactly, and hopefully enjoyed. But even if it's functional and user-friendly, there's another big factor we have to consider. Can you count on it when you need it most? And that's where reliability comes in. Reliability, I mean, it's the difference between your banking app working smoothly on payday or crashing right when you need to pay rent. We've all been there.
Oh, don't even remind me. There's nothing worse than a system crash when you absolutely need it to work.
Right. So how do you actually build software that can withstand, pretty much anything life throws at it?
Well, that's what reliability is all about. It's about building that resilience into the system. We're talking about things like availability, like, is it even up and running when you need it? Fault tolerance, can it handle errors gracefully without, completely freaking out? And recoverability, can it bounce back quickly if something major does happen? Because let's be honest, things are going to go wrong at some point.
Okay, so give me an example. What's a tactic that developers can use to make software super reliable?
One of the most crucial ones is something called failover mechanisms. So imagine you're booking a flight online, right? A failover mechanism basically ensures that even if one server crashes, your booking request is automatically routed to a working server. So no more frustrating error messages. You don't have to start the process all over again.
So it's like having a backup generator that kicks in during a power outage, but for software. Makes total sense.
Exactly.
So it's all about building in that redundancy so the system can kind of keep chugging along no matter what. But building truly robust software, it goes beyond just like keeping the lights on.
Exactly.
I got to ask about something Harrer brings up here because it seems a little counterintuitive. He talks about using, get this, boring technologies.
Yes, the boring technologies approach.
It's like in the tech world, we're all about the newest, shiniest thing. So to intentionally choose something boring, it's almost radical.
I know, right? But think of it this way. Sometimes the best solution is the one that's, been around the block, the one that's got that proven track record of just being solid.
Okay, so less about chasing trends, more about what actually works.
Exactly. It's like that classic sedan versus the flashy new sports car. The sports car might be exciting, but that sedan, it's going to get you from A to B reliably.
And probably fewer repairs along the way.
Exactly.
So it's not about being anti-innovation, it's about making smarter choices, choosing reliability.
Picking the right tool for the job, even if it's not the flashiest one in the toolbox. Let's move on. What about performance? Everyone wants fast software, right? Nobody wants to wait for things to load. So what does Harrer suggest for, making sure our software is as performant as possible?
So he covers a lot of the usual suspects like caching, load balancing, making sure things are processed asynchronously, optimizing the code, all that good stuff.
Yeah.
But he also talks about this technique called data deduplication, which I thought was really fascinating.
Data what?
Data deduplication.
Oh, what in the world is that?
So it's basically like, imagine you'd have the same data stored in multiple places.
Right, okay, yeah.
So instead of storing it multiple times, you store it once and just reference it wherever you need it.
Oh, so it's like those, file compression tools, but for data in general.
Exactly.
Yeah.
It's really clever, right?
Yeah, it is. It's like, why didn't I think of that?
It's a win-win. It improves performance because you're using less storage, less bandwidth, and it's better for the environment, too.
I like it when those things go together. Okay, so we've covered functionality, reliability, usability, performance. We have to talk about security.
Of course.
That's something I'm really passionate about. So what are some of Harrer's top tips for building secure software, like from day one, not as an afterthought?
Right. And he's very big on that. Like, he really emphasizes this idea of security by design.
Meaning?
It's not enough to, tack on security at the end, right?
Yeah.
You have to be thinking about it from the very beginning.
Baking it in from the start?
Exactly. And he gives, really concrete examples of how to actually do that. How to integrate security into your architecture from the ground up. It's not just this, vague advice. It's very practical.
I love that. So it's kind of it's like disaster recovery, right? You don't want to wait until the disaster happens to figure out your plan.
Exactly.
You have to be prepared. Okay, so security, check. What's next? Oh, right.
You also have to make sure that it can adapt and evolve over time, and that's where maintainability comes in.
Right, because nobody wants to deal with a code base that's just like a tangled mess. Ugh, tell me about it. It's like trying to read a book where someone's glued all the pages together in random order. It's impossible.
Exactly. Maintainability is all about making sure that the software is easy to understand, easy to modify, and easy to keep running smoothly over time. And it's not just for the developer's sanity either, although that's definitely a factor.
Sure.
Well-maintained software means that updates are smoother, new features are easier to add, and the whole thing is just less likely to break down in the first place.
So it's like building a house with good bones and really clear blueprints. It might take a bit more effort up front, but it pays off big time in the long run.
Exactly.
So how do you actually make software maintainable? How do you do that? One of the key concepts that Harrer talks about is this thing called domain-driven design. Have you ever been in like a meeting where the tech people are talking in all this jargon and then the business people are talking about something totally different and it just feels like nobody's on the same page?
Oh my gosh, all the time.
Yeah.
It's like trying to have a conversation in two different languages.
Exactly. And that's exactly what domain-driven design tries to solve. It's about creating this shared language and understanding between the developers and everyone else who's involved in the project.
So you're making sure that the software's design actually reflects the real-world concepts it's supposed to represent.
Exactly. It's like making sure everyone is speaking the same language from the get-go, no matter what their technical background is.
That makes a lot of sense.
And when that happens, the code base actually becomes a reflection of the business itself, which makes it way easier for anyone to understand and modify down the line.
That's fascinating. And it sounds like it would prevent a lot of headaches.
Oh, definitely.
What other tactics do developers use to kind of build more maintainable software besides this domain-driven design?
Well, remember those solid principles I mentioned earlier?
Vaguely.
Yeah.
They sound familiar,
Yeah.
but maybe give me a quick refresher.
Yeah, so those are basically guidelines for writing code that's, easier to change and extend over time. Think of them as best practices for building flexible, modular software. Kind of like building with Legos, you can swap parts in and out without the whole thing collapsing.
Okay, yeah, that makes sense. So maintainability is about like setting the stage for future success, right? Making sure the software can evolve and adapt as needs change.
Exactly.
And speaking of adapting to change, let's talk about compatibility. In a world where there are new devices, new operating systems, new software popping up all the time, it seems like it would be super important to build software that can, play well with others, both now and in the future.
Oh, absolutely. Because who knows what the tech landscape is going to look like in a few years, right?
Right. Everything's changing so quickly.
Exactly. Compatibility is about making sure that your software can integrate with other systems, adapt to different platforms, and handle those inevitable updates and changes without completely breaking down.
So it's about future-proofing your software as much as possible, making sure it doesn't become obsolete the second a new update rolls out. How do you even begin to do that?
One really effective way is by using standardized interfaces. Think of it like a universal language that different pieces of software can use to communicate with each other, no matter what.
So it's like you're building a software ecosystem where everything can coexist and understand each other, no matter where it came from or how it was built.
You got it. And Harrow gets into all sorts of ways to achieve this, like defining clear data formats and versioning systems, and also running really rigorous compatibility tests to make sure everything is speaking the same language.
It's like giving all the different pieces of software a dictionary and a phrase book so they can work together.
Exactly.
I love it.
And that's just one piece of the puzzle,
Okay. It sounds like compatibility is about thinking beyond just the immediate needs and really anticipating how that software will need to adapt and connect in the future.
Exactly. It's about building software that can grow and evolve along with the technology landscape, which, let's face it, is always changing.
Always, always. And there's one more quality characteristic we need to talk about, right? Portability.
Yeah.
So this is about making the software like easy to move around, like from one computer to another or one platform to another.
Yes, exactly. Portability is all about making sure your software isn't tied to a specific operating system or hardware or environment.
Okay.
It's about being able to move it around, deploy it in different contexts, and knowing that it's going to keep working as expected.
So it's kind of like having a universal travel adapter. You could just plug your software in anywhere and it just works. I can see how that would be super important, especially now with just so many different devices and platforms out there.
Oh, absolutely. And one tactic that's becoming increasingly popular for achieving portability is something called containerization. Have you heard of things like Docker or Kubernetes?
They ring a bell, but I'll be honest, I'm not entirely sure what they are.
So basically, they allow you to package up your software and all its dependencies into these self-contained units called, containers.
Okay.
It's kind of like imagine putting your whole application in a shipping container, right? You can move it from one ship to another without having to unpack and repack everything.
That's a fantastic analogy. So you're basically creating a portable environment for the software to run in no matter where it ends up.
Exactly. Think of it like this. You have this great app on your phone, but you want to be able to use it on your computer too. Portability makes that possible without needing like a completely separate version for each device.
So instead of having to build a whole new app for my computer,
Right.
they can just use containerization to just port it right over.
Exactly.
That's amazing, and I think that's just one of the tactics involved in portability.
It's really impressive when you think about it. And Harrer talks about using platform-independent programming languages, which is kind of a mouthful.
Yeah.
But it basically means writing code that can run on different operating systems without needing, major tweaks.
Right.
And he also gets into the nitty-gritty of things like configuration files that can be easily adapted for different environments. So
It's like giving the software like a set of instructions that can be understood anywhere, no matter the language spoken.
that's a fantastic way to put it.
Listening to all of this, it's really eye-opening to realize that creating truly high-quality software, it takes so much more than just, writing code.
Oh, yeah, for sure.
It's about thinking about all these different quality characteristics we've been talking about. We can't talk about software quality without addressing those little things that Harrer calls quality illusions.
Ah, yes. This is where it gets juicy. Like a magician revealing all the secrets.
Usability.
Think of them like a mirage. They might look like they're improving the user experience, but they could be hiding deeper problems. Or even worse, creating new ones down the line.
Ooh, sneaky.
It's really interesting. Sometimes those illusions, they seem like a good idea at first.
Oh, totally.
Like those skeleton screens, when a page is loading and you see those blank boxes.
Oh, yeah, like a little loading dance.
Right. So on the surface, it seems smart. It creates this illusion of progress, so you're not just staring at a blank screen.
Come on.
But
There's always a but.
if those skeleton screens stick around for too long, if they don't really match the content that's coming in, it can actually backfire. Yeah. Makes the user more frustrated.
It's like when someone says, be there in 5 minutes, and then they show up an hour late.
Exactly. 5 minutes, my pal. It's about being honest with your users, transparent.
Okay, so we've covered a ton of ground here. For those listening, what are the key takeaways from our quality tactics deep dive?
It boils down to this. Building great software, the kind that people love, it's not about ticking boxes on a checklist. It's about understanding what your users need, setting clear goals, and then picking the best tactics to achieve those goals.
And sometimes the best tactic is the most straightforward one, the one that simply works.
Exactly. Focus on the fundamentals. Build software that is, functional, enjoyable, and reliable.
It's about making people's lives easier, not more complicated.
It's like a juggling act, keeping all those different factors in the air at once.
It really is. That's a great way to put it. And
Yeah.
just like with juggling, it takes practice and finesse to really find the right balance.
Yeah.
So it's not necessarily about being perfect in every single category.
Exactly. It's more about making smart choices.
Right. So it's all about finding that sweet spot.
Exactly.
And, while those quality illusions we talked about earlier might seem appealing at first,
Right.
it's important to remember that true quality, it comes from focusing on those core aspects that really make software great.
Yeah.
No smoke and mirror.
It's about building that trust with your users, proving that your software is the real deal.
Well said. Now, before we wrap things up, I have a little challenge for you, our listener. Think about a piece of software that you absolutely love to use. Maybe it's an app, a website, even a video game. And ask yourself, what makes it so great? Which of these quality characteristics really stand out the most?
Yeah. Have you ever really thought about it?
Because when you start to break it down, you realize it's usually not just one thing, right?
Right.
It's this combination of factors that are all working together harmoniously.
Exactly.
The software is functional, it's easy to use, it's reliable, and so on. It just works.
And it works well.
Exactly.
Yeah.
And that's the magic of truly great software, isn't it?
It is.
It kind of just disappears into the background and lets you focus on what matters. So as you go about your day, I really encourage you to kind of look at the software you use through this new lens of quality. Think about the tactics we've discussed and see if you can spot them in action.
Yeah. It's like a whole new way of experiencing technology.
It really is. And with that, I think we've covered a ton of ground today.
We really have.
This deep dive has given you a really fantastic foundation for understanding the world of software quality. But remember, it doesn't stop here. Keep exploring, keep questioning, and most importantly, keep those apps running smoothly.
So much good stuff here. And for everyone listening, think about this. If you could add one quality tactic to Harrer's book, what would it be? What's your unique approach? Something he didn't cover. Until next time, happy building.